Good morning, everyone. So today we're going to continue on with some factoring. Yesterday, I had gone over the basic factoring with you with the different combinations of signs. So today we're going to build on to that just a little bit. And we're going to go over some simple factoring where there is also a GCF. So you'll notice the directions on this page say factor completely. So whenever you see factor completely, that basically means two things. One, it means you should always check for a greatest common factor first. If you do have a GCF among the different terms of your polynomial, you should definitely factor that out. It also means that if there is multiple steps of factoring that can be completed, that you should complete all of them in order to get the final answer. In Algebra 1, we don't have too many steps going on, but when you get into higher levels, you might have problems where you have to factor a couple layers down. But for our purposes today, we're just going to really focus on getting out a GCF first and then factoring from there. So if you take a look at the first problem, you might notice that in the beginning of the problem, we have a number other than 1 in front of that x squared. So if I have a problem like this, I can't factor and write in my parentheses x and x like we had done yesterday because there's a 2 there. And to get 2x squared, I would need 2x times x. And those are two different terms, so it just complicates things a little bit. But before I get into more complicated forms of factoring, which we will get to, but not today, you might want to look at all three of your terms first. If you can divide all three of these evenly by the 2 that you see in the front, then that will help kind of solve the problem that we're having here with this 2. So first thing you want to do is divide out the GCF. So all three of these terms here can be divided by 2. So that would leave me with just x squared plus x minus 6. Now, when you're factoring, the 2 doesn't just disappear into thin air. It would actually be a factor that we would put out front of those parentheses. Because remember, whenever we check our work for factoring, we always FOIL or distribute to get back to where we started. That 2 is going to have to be included there, or we're never going to get back to our original problem. So now once we divide that 2 out, we kind of ignore it until we put it in our final answer. Now we want to take a look at the trinomial that we have here and just factor this into the two binomials like what we were doing yesterday. So now I'm going to do x and x, right? That's how we were splitting up the x squared, because x times x equals x squared. And now we need those two factors of 6. So it'd either be 1 and 6 or 2 and 3 that are going to subtract to give us the middle term, which is just a 1. So does 6 minus 1 equal 1, or does 3 minus 2 equal 1? Well, 3 minus 2. So we know we're going to put in a 3 and a 2. Now remember from the sign thing yesterday, how does a 3 and a 2 combine to give us a 1? Well, we know we're going to have opposite signs. And if it's a 1, it would have to be a positive 3 and a negative 2. And remember, the sign that's here is always going to go on that bigger number. In this case, 3 is bigger than 2, so the 3 gets the positive, and then the 2 would get that negative. Now, if you need to check it, you can always FOIL to check it. So if you're checking your work here, you would get x squared minus 2x plus 3x minus 6. Now that's going to get you to x squared plus x minus 6. But then you would have to distribute that 2 to get back to your original problem of 2x squared plus 2x minus 12. Now, I'm not going to be foiling and checking every single problem as I go through this page, but that would be good for you to keep in mind. It's also a good strategy to use when you take quizzes or tests or things like that, where there's answers that are multiple choice format. You can always use the foiling or the distributing to get back to your original, and then that might help you narrow down some of your choices. Okay, so let's take a look at number 2. Now, we have this coefficient of 2 in front of our x squared, so we're hoping that everything will divide by 2. So we're going to divide by 2. And when we divide each of these terms by 2, 2x squared divided by 2 leaves us with just x squared. 14x divided by 2 is 7x. And 12 divided by 2 is 6. So now we're going to just look at what's inside those parentheses there and factor that. So we're going to break up our x squared into x times x. Then again, we need those factors of 6. So we already know that the factors of 6 are 1 and 6 and 2 and 3. But this time we need those factors to add to get that positive 7 in the middle. So 1 and 6 are going to have to be the numbers that we use here because those are the ones that add up to 7. Now, when we have a positive here, right, the two numbers are adding up to get that middle number, we know both of these have to have the same sign. And since it's a positive 7, they're both going to be positive. All right, so let's look at number 3. Okay, again, it looks like this problem, we can also divide everything by a 2. There's that common factor there. So if we take out the 2, we're left with x squared minus 5x plus 6. So now we want to write down our two factors for that trinomial. And we know that we're going to have x and x. But again, we're going to look for our factors of 6. And which of those pairs is going to add up to get us 5? Well, 2 and 3 would add to get 5 rather than 6 and 1. So I know I'm going to be using my 3 and my 2. And now to figure out my signs, remember when there's a plus here, the signs are the same. And because this is a -5, they both would have to be negative. So that makes sense because -3 and -2 would equal -5 when you add them or combine them. But when you multiply the two negatives, you get that positive at the end. All right, so now we go to the next example. We've got all 3 of our terms are divisible by 2. So we're going to have x squared minus x minus 6. And then we're going to finish factoring that part. So again, the factors of 6, that's subtract to get me a 1. That would be 2 and 3. So I know I have x and x. I have my 2 and my 3 in there. I always put the bigger number in the first parenthesis. Now this time, the negative tells us that, yes, there's 2 numbers would subtract to get us the middle number, but also it tells us that these are going to have different signs. The bigger number always gets the sign that's here, so that would be 3 in this case, which means the 2 would get the positive. If you want to combine those 2 numbers together on your calculator in your head, make sure you get the -1 here in the middle. -3 plus 2 would be -1. -3 times 2 is -6. All right, next problem. So we're dividing by 2. So this time we have x squared plus 4x plus 12. And I'm looking this time for my factors of 12. So I have 1 and 12, 2 and 6, and 3 and 4. So which of those pairs is going to add up to get that 4 in the middle? Well, unfortunately, are any of these going to add up to get that number in the middle? No, 1 and 12 adds up to 13. 2 and 6 adds up to 8. 3 and 4 adds up to 7. So in that case, this is no longer factorable. Oops, sorry. So all you can do is basically leave your answer like this. Now, there are other methods that we're going to learn probably next week or so, where you might be able to still factor this original problem or things like that, but we're not going to get to that for now. For now, if there's no combination that works there, you're just going to leave it. All right, so then the next problem, 2, 14, and 12. So dividing everything by that 2, we have x squared minus 7x plus 6. So we're going to look for the factors of 6 that are going to add up to get that 7 there. So we know that that would be 6 and 1. And because the 7 is a negative, and the bigger number is definitely a negative, right? But this positive here tells me the signs are the same. So they're both negative, -6 and -1. Now make sure you realize that your final answer is including that 2 also. So it's not just the 2 parentheses, it's also including that 2. So when we take our quiz on Friday, you'll notice all the multiple choice answers for these kind of problems have like their GCF out in the front as well. All right, so I'm just going to skip down, do a couple others. If you're looking at, let's say, number 8, for example, this time we have a 3. So this time, what are we going to divide everything by? Well, 3, because you want to get rid of that number in the front. That's basically your goal. So if I divide everything by 3, now 3x squared divided by 3, the 3's cancel out. You would just get x squared. Negative 15x divided by 3 is going to be negative 5x. And negative 42 divided by 3 is negative 14. So now, same process. This time we're looking for the factors of 14. And we want the ones that subtract to get that 5 in the middle. So the 2 factors here that subtract to get 5 are 7 and 2. I always put my bigger number in the first parenthesis. And now we know that the signs are different because that minus right there, the bigger number is going to get the negative. So 7 gets the negative and 2 gets the positive. And that's our answer there. All right, and then I'm going to skip down to numbers 10 and 11. All right, so number 10 this time, what are we going to divide by? If you said 5, you are correct. We're going to divide everything by 5 because that's the number in front of our x squared. So that's the one we want to get rid of. Once you make it just a regular x squared without a number in front, everything else is much simpler then, because then you can just split up your 2 parentheses. So now we have x and x, right? But this time now I need the factors of 4, so either 1 and 4 or 2 and 2 that add up to get 5. So 1 and 4 would add up to get 5. Because it's an addition sign at the end, the signs are going to be the same. The 5 tells me that they're both going to be negative. So this would be my answer for that one. And then finally, we're going to do number 11 here. So if I'm dividing by the 4, because I want to get rid of that 4 in front of my x squared, that leaves me with just x squared plus 6x minus 16. So now I can factor out that trinomial there. I need my factors of 16, which are 1 and 16, 2 and 8, or 4 and 4. And I need to know which of those pairs will subtract to give me a 6. So what's it going to be? 2 and 8. So in order for me to get a positive 6, I would need a positive 8 minus 2, right? But you know the signs are different because of that negative there. The 6 tells you it's positive, so the bigger number gets the positive, the smaller number gets the negative. All right, so now let's move on to the next page. And you'll notice here the directions say solve by factoring, right? So solve the equation by factoring. On the last page, we were just factoring, and then we were done. We were leaving our answer just written as factors. But this time, we're going to use that process of factoring to help us then solve the equation. And you might remember yesterday, we talked a little bit about the zero product property. So we'll use that to get our solutions at the end. So first thing we want to do here, just like we did on the last page, is that you want to get rid of that number in front of your x squared. So just like we did on the last page, if you can divide out that number, because everything is divisible by 3 in this case, you definitely want to do that. So first thing we take out is that 3. So we're left with x squared plus 3x minus 4. So then the second step, same thing we did on the last page. We're just going to factor this trinomial in here, so x and x. Then I would need my factors of 4, 1 and 4, 2 and 2, that add up to get 3. Well, or sorry, subtract to get 3, because that's a minus sign. So 4 minus 1 would give us the 3, right? So I have a 4 and a 1. The subtraction means the signs are different, so the bigger number gets the positive. 4 will be positive, 1 will be negative. Okay, so now on the last page, at that point, we were finished, right? We were just factoring, done. But now we're going to use these factors to actually get our solution. So if you remember back to zero product property, all your factors, you're going to set them equal to 0 and solve for x. Now, the first factor is just a 3, so I don't have to do anything with that. There's nothing for me to solve. There's no variable. If there was an x next to that 3 or something, then I would need to solve it. But since there's no variable, I don't have to worry about that one. Now, the x plus 4, if that equals 0 and I go to solve it, I get x equals -4. That's one of my solutions. Then the other factor that has a variable is the x minus 1. So if I use zero product property to solve that one, I get x equals 1. So when you do these problems, typically what happens is whatever your exponent is, that's how many solutions you're going to have, because that's how many x's you're solving for usually. There are a few exceptions to that, but generally speaking. So x squared means that there's 2 x's, so I should have most of the time 2 solutions. So let's take a look at number 14. So if I'm doing number 14, this time I have a 6 in front. Now, if you go to divide by 6, right, you're going to get x squared, but then then you're going to run into a little problem, right? Because 10 divided by 6 is 5/3, and 4 divided by 6 is 2/3. So you're not going to do it with fractions. We don't factor with fractions like that. So then you would just say that it's not factorable for now. Now, this particular problem might be factorable using another method, but we haven't learned that yet, so I'm just going to leave it like that for now. Okay, so number 15, let's try that one. So again, just like we did on the last page, we want to divide out whatever number is the coefficient on our x squared. So that would be a 2. So if I divide out the 2 here, I'm left with x squared minus 11x plus, I believe that is 28. Then we would want to continue factoring that trinomial if it's possible. So x and x. Then I need my factors of 28. And I did provide you guys with a factor sheet. So if you have that, or you can always Google one if you don't have one. It gives you all the factors for every number from 1 to 100. It might be a good little resource so you don't have to think so much or use your calculator or whatever. So which of those numbers or pairs of factors add up to 11, 7, and 4? So I'm going to put in my 7 and my 4. Now, the two numbers are going to have the same sign because of that addition sign there telling us that. The bigger number and the smaller number will both be negative. And that makes sense because when you combine those two numbers, -7 and -4, you would get that -11 in the middle. But if you multiply them, you get the positive 28. Now we have to get our two solutions. So our two factors that have x's are x minus 7. So we solve that factor using zero product property. And then the other factor of the variable is the x minus 4. So we solve that one using the zero product property. And we get our second answer. And then the 2, we didn't have an x or a variable with that 2, so we didn't have to worry about solving that factor. All right, so then the next set's just a little bit more practice with these same types of problems here. So this one, we have the 4 in the front. So we divide out that 4, leaving us with x squared minus 6x minus 7. And then we go ahead and continue factoring that problem. X and x, the factors of 7 that subtract to get 6 are 7 and 1, right? 7 minus 1. But it's a -6, so the bigger number gets the negative and the smaller number would get the positive. And you might want to just double check in your head, do those two numbers add up to -6 and do they multiply to get -7? Then the two factors that have the x's, we set them equal to 0, and we use zero product property to get our two solutions. So here we have x equals 7, and then over on this one, we get x equals -1. Okay, so then the next problem here, we have a 5 as our coefficient on that x squared, so we want to divide out the 5. When we divide out the 5, we get x squared minus 6x plus 9. Continue factoring that. So x and x, the two factors of 9. Two numbers multiplying at 9 that add up to get 6. What are they, guys? 3 and 3. And same signs, both negative. And you'll notice in this particular problem, both of your factors are the same. So when you go to solve these, you're going to get the same answer twice, right? You're going to get an x equals +3. And then here you would also get x equals +3. So sometimes that's what I was saying, even though you have technically two solutions there, they're the same. So it's really like having one solution. So that's like an exception when I said x squared usually means you're going to have two solutions. So you can still solve for two, but in this case, they're the same. So you don't have to write it twice, but that would be one of those exceptions. And then number 18, we're going to divide by 3. So when we divide all of that by 3, we get x squared plus 8x plus, let's see, 15. X and x. Now, what are the numbers that are factors of 15 that add up to 8? So that would be 3 and 5. And addition here means the signs are the same. This one means they're both addition, which makes sense because 5 plus 8, or 5 combined with, or sorry, 5 and 3, when we combine those like terms, we get 8. When we multiply them, we get the 15. And then we would want to solve each of the factors that have our variable using zero product property. So for the first one, we get -5 as our first solution. And for the second one, we get x equals -3. All right, so moving along, when we're solving quadratic equations using factoring, it's nice when they're set up in standard form. And if you remember, standard form is when everything is on one side of the equal sign, equals 0. Okay, so continuing on, if we take a look at number 19, 20, any of these, we'll notice that they don't equal 0. So whenever we're solving a quadratic equation, you have to have it equal 0 before you can use any method. So first thing we're going to have to do for these problems is bring anything that's on the other side of the equal sign over to the side with everything else. So we want everything on one side. So whenever you're going to move something over from one side to the other, you want to do the inverse operation. So addition or subtracting, whatever one you need to do. So here we would have to subtract 6. So this would make our problem x squared plus x minus 6, and now it equals 0. That's what we want. Once you get it to equal 0, you're doing the exact same thing we did yesterday and earlier. And on these notes, you're just factoring it like normal. So x and x, what are the two numbers that multiply to get 6, that subtract to get this one in the middle? So the two numbers that subtract to get the 1 would be 3 and the 2. Now, it's a -6, so I know they're opposite signs. The bigger number should get the positive. Smaller number gets negative. 3 minus 2 does equal that 1 in the middle. And then you can continue solving using zero product property. So if you know x plus 3 equals 0, your solution there will be -3. And if you know x minus 2 equals 0, your solution there will equal 2. So number 20, this time we're going to move that 36 over to the other side by subtracting it. So we have 3x squared plus 33x minus 36. Now it equals 0, so that's good because that's what we want. Now this time we're going to divide out that GCF just like we did earlier on this page. So we're going to divide by the 3, we're left with x squared plus 11x minus 12. Continue factoring that. So we have x and x, the numbers that multiply to get 12, the factors of 12 that subtract to get 11 are 12 and 1, because positive 12 minus 1 would give us that 11. And then our two solutions here, if we do x plus 12 equals 0 and x minus 1 equals 0, well, negative 12 plus 12 equals 0, and 1 minus 1 equals 0. So those are our two solutions there. For 21, we're going to move that 56 over. Now we're going to divide everything by that 2 that's in the front, so we can get rid of that coefficient on our x squared. And now we're going to finish factoring that. So x and x, and the two numbers that multiply to get 28, or the factors of 28 that subtract to get 3, would be 7 and 4. And since it's negative here, we know they're opposite signs. This negative tells me the bigger number is negative, the smaller number is the positive. And then I would use my zero product property to solve, and I would get x equals positive 7 and x equals negative 4. Now you might notice at this point that whenever you're using zero product property, you end up getting the opposite sign of the number that's there, which for most of these that will happen when we move on to factoring with the coefficient in the front. Sometimes you'll get fractions and things like that. So for now it'll work out like that, but it won't always work out like that. Okay, now if you look at 22, you have to move this 30x over to the other side, right? So we're going to add 30x. The thing is, when we put it on the other side, you want to make sure you're putting this in standard form, so the x will have to become that middle term, and then the minus 35 will come after that. So just make sure you're putting it in that descending order when you move things over to the other side. Now we divide by the 5. So we're left with x squared plus 6x minus 7. Then we're going to finish factoring that. The factors of 7, well, there's only 2, 7 and 1, that subtract to get 6, are 7 and 1, positive 7, negative 1. And then our two solutions are going to be x equals negative 7 and x equals positive 1. All right, last two problems here. So this one, again, we're moving that 28 over. So when we move that 28 over, we're going to be adding it. And it's going to go in the middle because it's the x term. So we want to make sure that we always have it in order, x squared, then the x, then the constant. Now we want to divide all that by 4, because that was the number in the front there. X squared plus 7x minus 8. Continue factoring x and x. The two numbers that multiply 8, that subtract to get 7, are 8 and 1. Different signs. The bigger number gets the positive, the smaller number gets the negative. And then we were going to get x equals negative 8 and x equals 1 for our two solutions. And then our final problem, this time you might notice that we already have a trinomial here, but then we also have to get rid of this 4. So because the 4 and the 8 are both constants, you can combine them since they're like terms, and you get negative 12 there equals 0. This one does not have a coefficient in front of the x squared, so you can go right to your factoring. What are the factors of 12 that subtract to get 4? 6 and 2. Different signs. The bigger number gets the negative, the smaller number gets the positive. And then we know when we find our solutions using zero product property, we will get positive 6 and negative 2. And thanks for joining me today and learning about how to factor and solve quadratic equations when you have a coefficient in front of that x squared other than 1. Hope you guys have a great day, and don't forget to contact me with any questions.